theoretical probability. What do I mean by that? Well, in some of the earlier questions, we did an experiment and then looked at the data of the experiment and used that to make a prediction. Here, you are calculating the prediction, your probability, just looking at the possibilities that could happen before the event happens, making a prediction. So without collecting data, you're just calculating it theoretically on paper, without doing an experiment first. Anyway, one way that we can calculate the theoretical probability, if all outcomes are equally likely, is that we can calculate the theoretical probability of a certain event E happening as this formula. I think the easiest way is showing you how this formula works. So let's look at a specific example of Mr. Ranieri rolling a dice. I know that I will be corrected here potentially. Technically, if it's one of them, it's called a die. One die, two dice, three dice. But it doesn't really matter, does it? Anyway, Mr. Ranieri rolls a die. To make it easier to look at the outcomes, let's list the sample space. List all of the outcomes of rolling a standard six-sided die. What are the outcomes of rolling a standard six-sided die? There are 6. 1, 2, 3, 4, 5, 6. Notice that I've listed them in set notation, with the curly brackets at the end, separated by commas. Now that I've got them listed here, I can find the probability of getting a 3. So the event here, the thing that I'm looking for, is getting a 3. If this happens, did I get a 3? No. If this happens, did I get a 3? No. If this happens, did I get a 3? Yes! In fact, that's the only way that I could get a 3. So the probability of getting a 3, this event, is there is one outcome that matches the event divided by the total number of outcomes, which is 1, 2, 3, 4, 5. There are 6 outcomes. So the probability of this event happening is 1 out of 6. We can do the same for this event, getting an odd number. The probability of this event, an odd number, how many outcomes match this event of getting an odd number? There are 3 outcomes that match this event. So the probability of an odd number is 3 out of 6. If you're giving your answer as a fraction, it's a good idea to simplify your fraction. And we can simplify 3 over 6, divide them both by 3 to get 1 over 2. What about the probability of getting a 3 or a 4? The same sort of thing, probability of getting a 3 or a 4. There are 2 of these outcomes that match that event. So the probability is 2 out of 6, which is 1 out of 3. And finally, the probability of getting at least a 2. We can go through these outcomes one at a time. If I get a 1, did I get at least a 2? No. If I get a 2, did I get at least a 2? Yes. The same for 3, 4, and 5, and 6. At least 2 means 2 or bigger. So the probability of this event happening is 5 out of 6 because there are 5 outcomes that match the event and 6 outcomes in total. Just before I finish the video, I should point out this only works if the outcomes are equally likely. For example, suppose, that I get up to teach the class and, bounce around and draw things on the whiteboard. There are 2 outcomes there. Either I could survive, is one outcome, or I end up with a whiteboard marker in my eye, and then I die. So there are 2 outcomes there. But they're not equally likely, are they? It's not a 50-50 chance. So this rule here only works if all of the outcomes are equally likely to come up. And sure enough, in a normal die, assuming it's not loaded and weighted and a trick die and that sort of thing, then they're all equally likely. All right, I hope this has been helpful, and I will see you all next time. Bye, everyone.